All right, let's dive right into an absolutely incredible journey that's going to completely change how you view your favorite video games and honestly the technology you use every single day. Welcome to this explainer on what researchers are now calling the Ludic Age. So think about this for a second. What do a simple game of tic-tac-toe, the modern GPU humming away inside your computer, and the absolute most advanced artificial intelligence models in the world all have in common? I know, it totally sounds like a trick question, but the answer traces back through centuries of human history and mathematics. The surprising answer is that they were all driven by games. Seriously. The crucial takeaway here is that games are not just some fun byproduct of computing. Actually, scratch that. It's more like they are the fundamental catalyst that allowed computing to exist in the first place. Section 1. The Ancient Play Instinct. To really wrap our heads around this deep connection, we have to start by looking at why we play in the first place. Neuroscientist Kelly Clancy hit the nail on the head when she said that games speak to something deep in us, beyond time, culture, and language. Play is a totally ancient instinct. But while animals play to practice physical skills, like a kitten pouncing on a toy to practice hunting, we humans uniquely use games to practice our mental skills in a safe, controlled environment. And this history goes way back. According to the ancient Greek historian Herodotus, the Lydian people supposedly invented many of our modern games as a survival mechanism during a grueling 18-year famine. They would literally alternate eating one day and playing games the next, just to distract themselves from starvation. It brilliantly illustrates how games have historically nourished us, effectively hacking our brains to give us pleasure and structure out of thin air. Moving to Section 2, Games Built the Computer. Now, this part completely flips our modern assumptions upside down. The common view we all kind of hold is that computers were invented first, and then they paved the way for video games to be coded. But the historical reality? It's exactly the opposite. Games provided the very mathematical logic that built early computers. We always think of games as just software we load onto machines, but the structural logic of games is what actually gave birth to symbolic computing. It's wild when you trace a direct line from 18th century chess puzzles right up to the dawn of the information age. Just look at this progression. In 1766, the mathematician Euler formalizes the Knight's Tour in chess. Jump to 1822, and Charles Babbage is studying chess to solve algorithmic problems, which directly leads him to conceive the analytical engine, the first mechanical computer, in 1837. By 1840, Ada Lovelace is mathematically analyzing the game of solitaire. All of these ludic milestones created the foundation for where we are today in 2024, where AI is now training in virtual game worlds. So, how did those early pioneers make the leap from board games to computing machines? Well, we have to talk about the geometry of situation. This was a mathematical theory describing these spatiotemporal relationships between objects, and it was pioneered specifically through the study of games. Mathematicians like Leibniz and later Babbage used games like solitaire and chess to develop this entirely new geometry. It basically allowed them to track sequences of action over time without relying on traditional grid coordinates. Get this. Charles Babbage actually mapped out the game of tic-tac-toe to invent the first recorded stochastic process. He was essentially analyzing randomness and probability mathematically. He analyzed the 9 possible moves, mapped every move against the others, created a search tree of branching outcomes, and then set out to mechanize that memory and foresight. He effectively wrote a program for the very first computer game long before actual computers existed, simply to test if a machine could have foresight. And Ada Lovelace was just as obsessed with this process. When looking at the game of solitaire, she famously wrote, "I want to know if the problem admits of being put into a mathematical formula and solved in this manner, put into symbolic language." Even Lovelace, who is universally recognized as the world's first programmer, was exploring abstract sequences of moves on a game board before she ever penned her algorithms for the analytical engine. The real mechanical result of all that brilliant thinking was something called the anticipating carry. This was an absolutely ingenious mechanism in Babbage's engine, inspired directly by the foresight and memory you need to play strategy games. By translating the rules and conditional logic of games into physical metal gears and punch cards, they created a machine that could literally anticipate and calculate sequences across time and space. All right, Section 3, Hardware Driven by Gaming. Let's fast forward to today. That historical connection between games and computing power has just exploded into a massive global economic engine, $200 billion. Just let that number sink in for a second. That is the estimated annual revenue of the global gaming market right now. And all that capital doesn't just sit there in a vacuum. It aggressively funds the frontier of modern technology.
When you look at giants like Nintendo sitting at a market cap of around $65 billion US, or Electronic Arts at $42 billion, you realize these companies drive enormous profits. And this massive consumer demand, in turn, heavily incentivizes the creation of faster, more powerful hardware components. Basically, the entertainment value of gaming foots the bill for our most serious scientific hardware advancements.
And the spillover effect here is absolutely staggering. Those GPUs that were originally built so you could play games with better, hyper-realistic graphics, those are the exact same chips driving today's artificial intelligence boom. Virtual reality, which was pushed heavily by gaming, is now transforming things like surgical training in medicine and immersive education. The relentless demand from gamers for zero-latency multiplayer experiences directly accelerates our 5G networks, cloud computing, and even global cybersecurity. Gaming touches literally everything.
Which brings us to Section 4, AI's ultimate training ground. At the cutting edge of software, games are currently solving the single biggest bottleneck in developing general artificial intelligence. Take DeepMind's Genie 2, for example. It's a foundation world model that generates endless, playable 3D environments from just a single prompt image. Because AI models need rich, incredibly diverse environments to learn how to operate in the real world, researchers have built systems that can instantly generate interactive game worlds for the AI to explore.
Inside these generated worlds, AI agents are actually using simulated keyboard and mouse inputs to learn action controls. They have to figure out complex things like moving a character instead of just panning the background. Remember that kitten playing to practice hunting? Well, we're now using video games as the ultimate training ground for embodied AI agents to safely practice complex reasoning and physical controls.
And finally, Section 5, entering the Ludic Age.
So we've really come full circle here, realizing that our entire technological foundation is absolutely inseparable from play. Think about the contrast. In the 19th century, humans used games to figure out how to build the very first computing machines. Fast forward to the 21st century, and we are using computing machines to build games that train autonomous AI. It is truly fascinating to see how the exact same mental instinct that helped Charles Babbage design the first computer is now being used by DeepMind to teach AI how to think.
So, I want to leave you with this final thought to really ponder the next time you look at the screens, the smartphones, and the complex systems that surround you every single day. If the ancient human instincts to play games is what successfully built computers and trained artificial intelligence, what new reality are our machines currently practicing for? Thank you so much for joining me for this explainer. Keep learning, and I'll catch you next time.